Welcome to Stargazing in the Spring with Dave McDonald. This is a Harris Center program. And for those of you who are new to the Harris Center and maybe aren't from around here, I'll just give you a quick rundown. The Harris Center is located in southwestern New Hampshire in a little town called Hancock. We have been operating for the past 50 years as a land trust, and part of our mission as a land trust has always been to help people connect to the natural world. We do this through education of people of all ages, from very, very young to people at all stages in their life. We also offer lots of hikes and community programs, work in the schools. We have a really active conservation research program that we run where people can do studies on our lands, and also community science happens here. Salamander brigades and nighthawk watches and cyanobacteria monitoring are just some examples of our conservation research. And last but not least, we are actively helping to protect land for wildlife and for people. And you can find out more about the Harris Center by visiting our website at harriscenter.org. And all of these programs that the Harris Center puts on happens because of supporters, and we might have a few supporters out here this evening, so I want to thank you. And if you're ever interested in helping to support the Harris Center, you can check that out too on our website. So my name is Susie Spickle, and tonight I am really, really excited to have Dave McDonald back. He was here this winter, and some of you might be repeaters like me and loved it. Dave is an incredible astronomer and educator. He has taught astronomy at different high schools and colleges across this New England area. He was the director of the McAuliffe-Shepard Discovery Center and one of the educators there for a while. And he has even a TV show on stars and stargazing. And I'm not going to say anymore. I'm going to let Dave tell you about himself because he can do it better than me. And I want to just give him a big warm welcome because we're really big fans of him here at the Harris Center. So Dave.
Oh, thank you so much, Susie. I appreciate the kind introduction. Uh, hey, thanks so much for coming. I hope we're going to have a good time tonight. I plan to. And one of my objectives is that when the night is over, you learn 2 or 3 things that you didn't know before, and you got 2 or 3 things that you're going to go out in the night sky to try to find. Now, maybe there'll be more. So if you want to grab a paper and pencil just to jot down some ideas, as Susie mentioned, it's going to be recorded. You'll be able to, watch it again if there's a piece that you want to go back and review. But I'm going to share some things as we come upon May. There's some neat things happening in May. We're going to talk about the sky tonight, and I do think it's going to be clear tonight. But I got some neat things that are coming up in May. You might want to jot them down or on your calendar or something, or just listen and enjoy it and watch the recording. All right. So as Susie said, I teach astronomy in a lot of different places and colleges uh, and high schools. Currently, I'm teaching STEM and astronomy at Belmont High School in Belmont, New Hampshire. I am the senior educator at the McAuliffe-Shepard Discovery Center. I was the education director there for 10 years, and now I work there part-time 1 day a weekend. Still love keeping my finger in the pie there. And I do have a television show called The Sky this month, and we're going to talk, hopefully that'll be available to you as well. And the month of April, right now that we're in, is about solar eclipses that are coming up in 2024. It seems a long time away, 3 years away, but it's going to be here before you know it. And then the May show I just recorded yesterday after, and that should be up on April 30th. And we're going to talk about binoculars as well as the night sky, some of the stuff I'm going to be sharing here with you. All righty. So a little bit about the night sky. So those of you who were here last time with me, we talked a little bit about these things, and I thought it would be beneficial for our new viewers in particular. And as an educator, we review. That's just what we do. So we're going to talk a little bit about constellations, asterisms, distance, the magnitude scale, what do colors mean, the celestial sphere, and then we'll talk about what is up. So, constellations, well, they go back a while ago. In ancient times, when people had to watch television by candlelight, there wasn't a lot to do. So, just like probably you have done with friends, family, kids, when you were a kid, go out and look at the clouds. Oh, there's an elephant, there's a turtle, there's a cat on the back of the turtle. You know, we use our imaginations and enjoy the clouds. Well, they did that at night with the stars and imagined a number of things. So what you see here in the upper left is summertime is the constellation of Scorpius, the Scorpion, which is, I think, one of the constellations that you can imagine looking like that because it definitely has the stinger showing, and then Sagittarius, and that's they are next to each other in the night sky. And then in the right side, you can see again sketches. They made the maps. They put the stars, bigger circles for brighter stars, and smaller circles or dots for dimmer stars, and they kind of did some artwork there. And so mythology is a big piece of constellations as well. Now, an asterism is not a constellation. Asterism is a familiar shape which may be made up of stars from the same or from different constellations. The Big Dipper is not a constellation, it's an asterism. It's part of Ursa Major, the constellation of the Big Bear. The Great Square of Pegasus borrows its brightest star, Alpheratz, from Andromeda. So the Great Square of Pegasus, three stars are from Pegasus, and one is borrowed from Andromeda, for example. Now, when you go out and look at the sky, and the most familiar shape that we look at, the asterism of the Big Dipper, which in the springtime it's pretty much overhead. So if you go out, 9 o'clock ish at night when it's dark, and I love that it's getting lighter and lighter in longer afternoons. I enjoy the afternoon sun. And the days are going to get longer till we get to June 20th, which is the summer solstice. And maybe I'll be invited back. I could talk to you about the summer sky. But the Big Dipper, when we look at the stars, it looks like they're all there. They're all equidistant apart, and that's what the ancients thought. They thought of this thing called the celestial sphere that was equidistant all around as a sphere that we're inside of, and the stars were just there the same distance apart. Well, in reality, though that's the way it looks, stars are at varying distances. So you can see, I'll use my pointer that you can see. Uh, a lot of the stars in the Big Dipper, they're in the vicinity of what we call 80 light years. A light year is the time it takes light to travel in 1 year. Light travels really fast. 186,282 miles per second. Really fast. It takes 1.25 seconds for light to get from Earth. Like if I went outside and I had a laser pointer and I pointed it at the moon and you were on the moon, you would see my laser, if it was bright enough, you would see my laser pointer 1.25 seconds later. And that's 250,000 miles on average. The light from the sun is 93 million miles away, and it takes about close to 8.5 minutes for the light from the sun to get to us. Well, the stars, we're not talking seconds or minutes, we're talking years. And these nearest stars are around 80 light years away. This star at the end of the handle of the Big Dipper here, that star's name is Alkaid. I love Alkaid. It's 100 light years away. I call it the century star, and you can see that it's further away than these other five are. And Alkaid being 100 light years away, the century star. So whenever there's a century anniversary, I remember back in 2003, we were celebrating on December 17th, I believe, celebrating the 100th anniversary of the Wright brothers' first flight. Well, I went out and I looked at Alkaid and realized the light that I'm seeing on that star right here at the end of the handle of the Big Dipper left that star when the Wright brothers flew. Isn't that kind of cool? So the furthest star is this one, and that star's name is Dubhe or Dubhe, and it's 110 plus light years away. So distances to the stars vary from the closest star to us, which is in the southern hemisphere, around 4.25 light years away, which is that's the closest, to thousands of light years away. And when we get to talk about other galaxies, literally millions and literally billions of light years away. This is a big place. So the stars, when we look up in the sky, they're really at various distances from us. And I already told you the Big Dipper is an asterism. So this is from the fall, and these constellations are coming up in the early morning, like 4:30 in the morning. Uh, but I just wanted to point out, first off, notice that there is this zigzag shape all around Pegasus, and there's this zigzag shape all around Andromeda. All the constellations, there's 88 constellations, just like there's 88 keys on a standard piano keyboard. There are 88 constellations. We get to see about 67 of the 88 in the course of a year here in New Hampshire, and 40 plus or minus at any given time at night. And so the star Alpheratz is technically just inside the border of Andromeda, but we borrow that star to make up the asterism of the great square of Pegasus. This is an actual image of Orion. And you can see from this photograph, it's a color photograph, you can see the top left star looks a little on the reddish side. The bottom right star, as we look at it, looks a little bit on the bluish side. And the stars in the belt, this one here, the left star in the belt, Al Natak, is white in color. So stars have color, but they also have names. Betelgeuse is the upper left. The bottom right is Rigel. Stars, some of the brighter stars have names, often Arabic names, but they're also designated by Greek letters if you know your Greek alphabet. So you have alpha, beta, gamma, and then delta, epsilon, zeta, and this is eta, etc. So Betelgeuse is also known as Alpha Orionis, Rigel, Beta, or Vita is proper Greek pronunciation, Orionis. Arabic names are common because, again, back when we had to watch television by candlelight, uh, the area of Mesopotamia, Babylon, Baghdad was a cradle of astronomy thousands of years ago. And they seem to care enough to look up, enjoy, and name things and write those names down. So the names of most of the stars that they named are still in use today, thousands of years later. Libra is a summer constellation. Zubin Eshemali, Zubin El Ganubi. This means southern claw. That means northern claw. Because another story for another time, Libra was once part of Scorpius. So this is the Big Dipper, and these are the names of the 7 stars. Notice this is one thing that I want you to notice. This is something that you can do maybe tonight. You go out, find the Big Dipper, which, as I said, around 9 o'clock, should be dark enough. It'll be overhead. You'll find the Big Dipper. And look at the middle star of the handle of the Big Dipper, and you will notice, if you can see in this blue fuzz there, there's 2 stars. There's 2 stars. And most people, you go out and you look around and say, oh, that looks pretty. and you go back inside or get in your car or continue about your business, take some time to observe. The middle star of the handle of the Big Dipper is two stars, and you can see them without binoculars. If you take a little time and you look, you'll notice there's a brighter star and there's a dimmer star right next to it. The dimmer one is Alcor, not Al Gore, and the brighter one is Mizar or Mizar. So that's kind of a neat thing that you can show people, and it's pretty fascinating. Alcade, I mentioned, 100 light years away. It's my century star. And then you have Megrez, Thecta, Merak, and Dubhe. Merak and Dubhe are the pointer stars. A little later, I'll show you they point to the North Star. So that's a little bit about the Big Dipper. And again, notice there's color differences. We'll talk about that. This is what we know as the Hertzsprung uh, diagram, the Hertzsprung-Russell diagram. And those are the names of the two guys, Hertzsprung and Russell. I don't remember their first names. And they created this diagram. We're not going to go into detail now. This is like the diagram in astronomy. But notice at the top, you got these letters, O, B, A, F, G, K, M. And all astronomers are taught, how do you remember those letters? They don't really seem to make sense. They don't spell a word. But if you can remember, O, be a fine girl or guy, kiss me. Every astronomer knows that. Oh, be a fine girl or guy, kiss me. And the O stars over on the left are blue. The ones way over on the right, yeah, uh, are red. And at the bottom, you can see the temperature scale in Kelvin, 30,000-ish degrees on the left, down to 2,000 degrees. I mean, 2,000 is hot, but it's cool as far as stars go. So what do the colors mean? Well, you know, in your car, if you want heat in the winter, you move the dial to red and you get heat. In the summertime, it's hot out. You want air conditioning, you move the dial to the blue because that means cool. In a hotel, if you go to a hotel, oftentimes there'll be like a red dot on the hot water knob and a blue dot on the cold water. It's actually the other way around. Red stars are the coolest, up to around 3,000 Kelvin is the temperature scale. Orange stars are a little warmer, we're up to 4,000 Kelvin. Yellow stars are average, and that's our star. The sun is yellow, 5,500-ish Kelvin. White stars are, we're starting to get really hot now. White stars around 10,000 Kelvin, well, twice as hot as our sun. Blue-white stars are hotter still, and the blue stars are the hottest, over 30,000 Kelvin. Here are some stars that match, and some of them I'll be able to show you tonight. Arcturus rules the spring sky, and it's so easy to find. I'm going to show you Arcturus. I'm also a little later going to show you how big it is.
Hey,
It's a
Dave,
red. Yeah, go ahead.
there is a question. How do they know how hot a star is? They can't like take a temperature. So how
Oh,
do they
yes,
figure
they
that out?
can.
They
They
can,
do take their temperature.
no. All right, tell us about that.
So yeah, and just a little bit about that. There's an instrument that's called a spectrometer, and a spectrometer analyzes uh, color, so they can know what a color is like. But as far as knowing that the color means hot or cold, we can actually identify with that ourselves. If you think about a blacksmith with a horseshoe, for example, the blacksmith takes the horseshoe and goes to his furnace and puts it in there and it glows red. Maybe some of you have a wood stove, a Defiant or a Vigilant or whatever brand you might have. And in the winter, you got a lot of wood in there, you turn the lights off, it glows red, right? And if you get it hotter, it
My name's
starts,
Jeff.
and if you let it get hotter, it glows orange. And if you were to get it to glow yellow, it would be even hotter. And then you've heard the term white hot. Well, white comes after orange, really hot. What flame, if you remember back to your chemistry days, physical science days, what color do you want your Bunsen burner flame to be? Blue, right? Why? Because blue is the hottest flame. So on Earth, we know that that's what the colors mean. We know red is the cool, once you get it to glow, red is the cool. I mean, it's hot, but it's the coolest of the colors. And once you get it to yellow, it's getting really hot. Then white hot is really hot. And then when you get to the blue, it's really, really hot. So these spectrometers are used to look at stars, and they can very, very detailedly know what color it is, exactly what color it is, and they can determine what the temperature is. You'll be able to go out after tonight. You'll be able to go out and look at the sky, and you'll be able to see. You'll be able to tell, oh my goodness, I never noticed. That's a red star. That's a white star. That's a yellow star. You'll be able to tell. And those colors are related to the temperature. I hope that wasn't too long of an answer. Um, so I'm going to show you Arcturus, which is red, orange, Aldebaran, which is the eye of the bull in Taurus, which is getting ready to set. I'll show you that one. That's an orange star. Capella is a yellow star. I'll show you where to find that one. That's out tonight also. Uh, and our star, the sun, is yellow. Then you have the blue-white stars that are hotter still. Spica, I'm going to show you where that is. Mintaka is white. That's in the belt of Orion. Blue-white, Spica, I'm going to show you where that is. And then the hottest stars, Rigel, which is in the bottom right of Orion. So I'm going to show you where some of these stars are. And then one thing that I would love for you to grasp and do is go out and spend some time, let your eyes get adapt, because this is not the type of thing where you go out your kitchen door, stand on the porch for 5 minutes, and you can tell. You've got to go out your kitchen door, dress warm so you can stay out a while, because it's going to take your eyes 10 minutes, 15 minutes. Different people, different ages, but 10 or 15 minutes at least. Let your eyes get adapted to the dark. You know, turn your porch lights off. If you have to, give the neighbor a call, say, can you turn your porch light off, please? I'm out stargazing tonight. And hopefully you have a friendly neighbor and they'll turn their porch light off for an hour or two. And then look and you'll see, oh my goodness, the stars do have colors. And now you know what those colors mean. I'll show you what stars, have different colors. And again, you can rewatch the recording. So stars have color. They also vary in brightness. And we want to have a language to be able to talk about the brightness of stars. Well, how bright that? Well, it's pretty bright. Well, that one's not too bright. Well, there are actually numbers that quantify this. So years ago, 160 to 127 BC, there's this guy, Hipparchus, Greek guy. The Greeks, as well as the Arabs, the Greeks had a lot to do with astronomy. And obviously, we have Greek mythology as well. And that may be one reason why some designations of stars use the Greek alphabet. So you know about the Olympics, right? And what place are the first runners in? The first runner across the finish line finishes in first place. The one who's next best, next fastest, finishes in second place. So this guy Hipparchus decided that, well, I'm going to do the same thing with the stars. The brightest stars are going to be first place stars, and the second brightest stars are going to be second place stars. And he went all the way down, first, second, third, fourth, fifth place, to sixth place stars, which would be the faintest ones that they could see. And of course, they saw some stars back then we can't see now. They didn't have air pollution. They didn't have light pollution. They had dark skies. So first magnitude, brightest star, sixth magnitude, dimmest star that you could see. So he put together a scale and got his buddies together and said, would you agree, first magnitude, faintest? And they kind of agreed that, they didn't have any instruments, just their eyes. And they just said, I think the brightest star is 100 times brighter than the dimmest. So the first magnitude was figured to be 100 times brighter than the sixth. And that ratio stayed. And technically, that's the fifth root of 100. So you have the same multiplier, which is approximately 2.5. From first magnitude to second magnitude, first magnitude is 2.5 times brighter than second. Second is 2.5 times brighter than third, etc. So that means first is like 6.25 times brighter than second. So that was the scale that was developed. But what happened was we got instruments that could actually measure the brightness, like photometers, right? Light meters on your camera, for example, can measure actually how bright things are. And so they found out, you know what? The brightest stars are more than 100 times brighter than the dimmest stars. So they decided to keep the magnitude 6 as the dimmest. But because now they can quantify, they can measure the brightness using instruments, they had to go not just first place stars, but zero place stars. And they found some things that were like in the negative realm. If you're going to keep that same scale of 2.5, roughly 2.5 times brighter or dimmer from one magnitude to the next. So now let me show you this. The magnitude scale, the apparent magnitude, how things look. So 0 is pretty bright. There's a star named Sirius, which is like negative 1.4. And that's a star. It's the brightest star in the night sky, about negative 1.4. The naked eye limit, as we said, is about a 6. A full moon is around negative 11 or negative 12. The sun is like negative 26, really, really bright. So we have now this magnitude scale that gives us an idea of how bright things are. And I'll share some stars and how bright they are with you. So we just talked about that. Again, faintest, magnitude 6. To see a magnitude 6 star, I think, is rare where we live because we have, we got some, we don't have no air pollution. We don't have a lot, which I'm thankful for, but there's enough, and this haze and this light pollution. Seeing a 6th magnitude star in New Hampshire, maybe up in Crawford Notch, maybe on the Kangamangas Highway, maybe on top of Mount Washington, but not too many places. So here are some stars. Polaris, which is the North Star, is a magnitude 2. Spica, which I'm going to show you how to find tonight, is a magnitude 1. Arcturus, which I've mentioned to you already, is a magnitude 0. So it's 2.5 times brighter than Spica is. Sirius, the brightest star in the night sky, negative 1.42. Jupiter right now is a negative. Remember, Jupiter's a planet, not a star, but it's brighter than Sirius. It's negative 2.9. Saturn's about a 0.5, so it's bright, between a magnitude 0 and a magnitude 1. Venus, very bright, and it's going to be getting brighter in the evening sky. Right now, it doesn't look that bright because the sky is light around it, but it's going to move into the darker sky as time goes on. Mars used to be like a negative 2 this summer and in October, and because it's moving so far away, because Earth is pulling away from Mars, we're getting further and further away from Mars. So looks dimmer. So it's down to a magnitude 1.5, which is still brighter than the North Star.
Hey
So
Dave,
that's how.
there's a question about it. This is from Nancy, and she's wondering, she wants to know, does it matter at what elevation you are trying to view the stars for brightness?
Oh yes. The higher you go, the less atmosphere you're looking through. So yeah, that's why our I'd say our prized telescope is the Hubble Space Telescope. And why one reason it does so well for the size it is. I mean, it's pretty big, 10-foot mirror is good size, but it's above all the atmosphere. We have some ground-based telescopes that can see almost, and some of them claim to see better than Hubble, but they are huge, 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 huge to be able to get the same amount of light and clarity in what we call resolution. So yes, the short answer to your question is the higher in elevation you go, the better, the clearer the stars would be. I had the opportunity to teach uh, 3 astronomy classes on the top of Mount Washington for a day, a night, and another day. And obviously, the nighttime viewing is it's crazy. It's absolutely amazing. So yes, the higher in elevation, typically, the better. Sometimes we have what are called temperature inversions, and sometimes the atmosphere is unstable up there. But I would say, generally, as a rule, the higher in elevation, the the clearer you'll see. All righty. Uh, the celestial sphere. You don't have to. There's not going to be a quiz tomorrow about these terms, okay? But we have Earth here. Earth has a North Pole, and you may know that Earth has a tilt to its axis, which is 23.5 degrees, 23.44. So we rounded to 23.5 degrees is the tilt. And that, you can see my pointer here with the red, all right? And that axis points towards the North Celestial Pole. And the North Star is really close to it. It's not exactly pinpoint. It's like 3/4 of a degree off, but it's close enough for state work. The celestial equator is a projection of our equator on Earth up on the sky, which pretty much runs through the belt of Orion. And Earth turns. So remember, the rotational axis of our Earth is pointing to the North Celestial Pole. And so, as Earth turns, we see the stars move around. This is the Little Dipper, Ursa Minor. This is the Big Dipper, Ursa Major, which is an asterism. And so looking north, things rotate that way, because over here on the right, as we look north, this would be east. So you'd see these stars are, so to speak, rising in the east and would go up and come around. And then over on the western side, they would come down. These particular stars are called circumpolar because they go around the pole. They're always up.
So Dave, that brings me to a question that came up from John. He wants to know, why are there different constellations up during the different seasons? And does this have to do with
Uh,
this?
that's coming right up.
Okay. All
Perfect
right.
lead-in question. So hang on, John. This is it. Perfect timing. All right. So this is Earth in the middle with this kind of rose-colored, pinkish color orbit. That's Earth. Obviously, in the middle is the sun. And around on the outer are stars. And obviously, drawing is not to scale because the distance from sun to Earth is 93 million miles, and the distance from Earth to those stars is hundreds or thousands of light years. But so here we are in January, right? And so you may know that Gemini is a winter constellation that you see in the sky in January. So you're here on Earth and you want to be in the nighttime, so you're on the other side away from the sun, and you look up in the sky and you see Gemini. You cannot see Sagittarius, right? Because the sun is in Sagittarius, so to speak. So Sagittarius is out in the daytime, so you can't see those stars. So as Earth makes its way around over here to March, which is, we're just past March, we're in April now. So let's say we're in April where the arrowhead is here, and we look up in the sky away from the sun at night, and we see Leo, and I'm going to show you how to find Leo tonight. We see Leo in the night sky in April. We do not see Capricorn in the night sky. Aquarius, I'm going to show you, is going to be popping up in May, and there's a meteor shower related to that. There's a meteor shower in May we'll talk about. And so we're not going to go through a whole year, but let's just get on the other side of January, right? So you got January, February, March, April, May, June, right? Summer solstice is June. So over here in this pinkish area that I'm pointing to, that's where the sun is in June. So in June, we see Sagittarius in the night sky. We cannot see Gemini in the night sky because as Earth goes around the sun, Earth is over here now in June. The sun is in the way. The sky is blue. We can't see the stars of Gemini or Taurus in June. But we can, at nighttime, see the stars of Sagittarius, where we could not see Sagittarius in January. All right, did that help? Hopefully the answer is yes. And these constellations are known as the zodiacal constellations, or the constellations of the zodiac. And just as a quick, I don't want to get into the discussion now because it would take a while, but there's another constellation right over here. There's a constellation called Afayucus, and his feet, the calves of his legs and his feet come down in here. So there's really 13 signs of the zodiac. The sun goes through 13 constellations, not 12. And the sun's apparent path, so this line that goes around here, this white line that circles around, is called the ecliptic. The ecliptic is the pathway of the sun. Technically, it's the pathway of Earth around the sun, but we're on Earth, so it looks like to us the path of the sun through the sky. Now, here are some of those funny shapes and some of the constellations. And so I've labeled this line here as the ecliptic. The ecliptic, for practical reasons, is the pathway of the sun through the constellations. So you see Pisces, Aries, Taurus, Gemini, Cancer, Leo. And right now, and you can see how curved this is. This is a fisheye view, which almost has, this must be, who knows, close to the Arctic Circle. All righty. All right, let's just talk about size. Obviously I want to get to the night sky. How big? I'm going to get to Arcturus, because Arcturus, you're going to love Arcturus. Arcturus is going to be your favorite spring star. Spica might be just because it's a very pretty blue-white, but Arcturus is really bright. So let's get there. So here's Earth. You can see Earth down here at the bottom, right? I'm pointing to. And then just about the size of 1 pixel is the planet Pluto. And then we have Neptune, Uranus, Saturn, Jupiter, and our sun is huge. We can put 109 Earths across the face of the sun. So compared to Earth, The sun is huge. About 1.3 million Earths can fit inside the sun. So here's our sun. And in comparison, Sirius, the brightest star in the night sky, Pollux, one of the twin stars, and here's Arcturus. I'm going to show you where to find Arcturus tonight. But look how huge Arcturus is compared to our sun. And notice the color, it's kind of reddish. So I think I'm going to, I'm going to leave that there. I'm going to stop sharing for a moment. If you have some questions you want to ask, I'm going to shift, and it takes about 30 seconds or so for my night sky software to engage. It's called Stellarium. Okay.
Here's a question. Are the constellations and the moon phases completely different in the southern hemisphere?
The moon phases are the same. The moon looks a little different because of its orientation. So it could look like upside down. The phases are the same. The constellations, there's a whole new set down there that we don't see at all. If you lived on the equator, in the course of a year, if you lived on the equator, like in Ecuador, Quito, Ecuador, you would see all 88 constellations in the course of a year. And the North Star would be right on the horizon. We don't have a southern star. There actually is one there, but it's not bright enough to see. So we don't actually get to see it.
Oh, cool. All right. And here's one other one while you're loading up your magic night sky show.
Working on it.
How do you judge the distance between the stars in a constellation? So such as the Big Dipper, how would you know what the distances are between them?
You would have to look it up.
You
Yeah.
have to look it
I
up,
mean,
right?
you can, there are different ways, like using your fingers, 3 fingers, 5 fingers, a fist. A fist is about, from pinky to thumb, is about what we call 13 degrees of the sky. But that's, in degrees. And that's roughly an hour. So if you put your pinky on the horizon at arm's length, where your thumb is about an hour's worth of time. So I know that when my pinky is on the horizon and the sun is on my thumb, I know I got about an hour left before the sun sets. But as far as the actual distances from the stars, because to us, they just look like they're plastered on this celestial sphere at equidistance, and they're not. So you have to look them up on a chart or in a book.
Okay, there is just a really good question that just came in from Deborah. I wondered about this too. Are stars just gases like the sun, or are they matter like Earth?
That's an awesome question.
I know, right?
It's gas. Yeah, there's nothing solid in. So yeah, stars are great balls of gas, if you would say, great balls of fire, right? Um, yeah, there's no solid pieces there, except that it's made of, protons and electrons, neutrons, those types of particles, and a lot of what we call free electrons, and it's a plasma. So there's 4 states of matter. We're very familiar with solid, liquid, gas. And then when things get really, really hot and electrons start moving so much and so violently that they basically shake off from their proton of their molecule, and you get this soup of free electrons, we call it a plasma. So yeah, so that's a great question. So it's not solid, it's a gas, it's a plasma technically. So we're facing south, and this is from Concord, and this is tonight. So I don't know, depending on the size of your screen, way down at the very bottom, you can see 2021, 4/23, 1948, which is the time that it is now. So it's like 7:45 right now. and you can see the moon is in the sky. It looks full, but it's not a full moon tonight. It's actually, as I said earlier, it's a waxing gibbous moon. So what I can do with the software is I can make the sun come down and have it get darker and the stars come out. And so we're going to go to 9 o'clock, which is pretty much what I have here. That's 2100 hours. And we're facing south. So I want to show you how to find some things. Now remember, the moon moves, right? So the moon is not going to be in the same place tomorrow night because the moon is always on the move. So overhead, there's the Big Dipper. You can see I'm circling it here, right? So that's pretty much overhead, 9 o'clock, 10 o'clock at night in the springtime. Okay, in the fall, at this time, it's really close to the horizon, right? It's just like a clock, it's halfway off. So you can see the Big Dipper, and you see the arc of the handle of the Big Dipper here. It arcs, and you can see just off. Let me see if I can bring it around here a little bit. And if you follow the arc of the handle of the Big Dipper, see, it arcs to the star Arcturus. Arcturus is the brightest star in the springtime sky, a magnitude 0 and red. So magnitude 0, very bright. Red, cool as stars go. And we also know it's big. We saw how big it was in relationship to our sun. So I'm just backing off a little bit here so we can see more things at the same time. Again, the moon is there, but the moon tomorrow night, so I can show you tomorrow night, it's going to move on us. So see how it moves. This is where it is tonight. Tomorrow night, it's going to be there. The next night, it's going to be there. So the moon moves from west to east against the background of the stars. Remember I showed you the fist? It moves about a fist's width from night to night. So if you put your pinky on your right hand out in front of you where the moon is on the left side of the moon, where your thumb is, that's where the moon will be tomorrow night. So there's your arc to Arcturus. And I want to show you a constellation. It's called Boötes the herdsman. But you know what? I don't see a herdsman. I see an ice cream cone. So I'm going to put up some lines here. And you can see the Big Dipper. And you can see all these other lines coming out of the Big Dipper. Because remember, the Big Dipper is part of the Big Bear. So Ursa Major is, I'm going to just try to, just so you can see more of the bear. So you can see you got a head, you've got front legs and paws and back legs and paws. So really Ursa Major, the big bear, that's not really too bad. It's got stars in the right places to make a bear, just a very long tail. Okay. And when you arc the handle of the Big Dipper, it arcs to Arcturus, bright red jewel-like. It scintillates. It almost seems like it changes colors. And it's at the bottom of the ice cream cone. Do you see the ice cream cone? Coming up here, coming up here. And so that is Boötes the herdsman. So I'm going to put up an image so you can see what an artist's conception of the herdsman is. But I see an ice cream cone. Maybe this is some whipped cream if you want to make it into a sundae. Cherry on the top. And these stars, you can see, they're plenty bright enough to be able to see. And look over here to the left of the ice cream cone. That's called Corona Borealis. That's the northern crown. It at least looks like a tiara, if not a crown. So let me put that artwork back again, and you can see the crown. Now, I'm going to take us just a little deeper into the night to 10 o'clock. Okay. So remember I mentioned that star Spica that was blue-white, very hot and very beautiful. So you can see here's the Big Dipper up at the top of your screen. There's the 3 stars that make up the handle of the Big Dipper. Remember the middle star is 2 stars in one, Mizar and Alcor. Uh, so don't forget to look at the middle star of the Big Dipper and see if you can see 2 stars. But you follow the arc of the handle of the Big Dipper and it arcs down to Arcturus, bright reddish star, can't miss it. And then you spike down towards the horizon to Spica. You see down here at the bottom of your screen, and you can see it's a little bluish in color, depending on the monitor you're looking at. And Spica is a magnitude 1 star. So now you have a gauge. Arcturus, magnitude 0 and red. Spica is a magnitude 1, 2.5 times dimmer, and it's blue-white, very, very hot. The lines you see around Spica, the way they connect them, I think kind of looks like a snail or a slug, but it is the constellation of Virgo, Virgo the Virgin or Virgo the Maiden, and Spica is typically referencing a sheaf of wheat or an ear of corn. Sometimes it's drawn to be a ring on her left hand. And Virgo is one of the constellations of the Zodiac. Okay.
Hey, Dave, what program are you using? People are curious. What is
Oh,
this?
they're curious.
Yeah, they want to know what is
Like
this
George?
thing?
Like,
Yeah, curious
like
George.
George?
Yeah, I don't think it was George who was curious, but people like this and they want to
Good,
know
good.
how
It's called Stellarium.
Stellarium.
Stellarium. Stellarium. Stellarium. And it's free.
Wow, free. I like that.
It's great. And I think, well, you can put it on your phone too. Um, so the next constellation I want to show you, which I mentioned kind of rules the spring sky as constellations go, and that's Leo the Lion. You can see the lion right here. Tonight, the moon is like on the head of Virgo and just behind the back legs of the lion. So let me just remove that for a moment. And you can see this backwards question mark, or what we call the sickle of Leo. And over here, there's a triangle. So that's Leo the lion. And so let me just push this up. So you see, we're looking directly south, right? So this is 10 o'clock tonight, 10 o'clock tonight, looking directly south. And the Big Dipper is overhead. And underneath the Big Dipper, right, there, you can see the Big Dipper at the top of your screen. So underneath the Big Dipper is Leo the lion, looking south. Tonight, the moon is right nearby, but you'll be able to find the backwards question mark, which represents the head of the lion. The star here is Regulus. Regulus represents the heart of the lion. Then you have the hind haunches, and the star at the end of the triangle is called Denobla, and it is the tail of the lion. So if I bring the artwork back, you can see the lion. And again, tonight, the moon is on the head of Virgo the Virgin, or just behind the back legs of the lion. And tomorrow night, the moon will be here, right? That's Saturday night. Sunday night, it'll be down here by her thigh. Then Monday night, down this way. Tuesday night, entering Libra, the scales. Okay, well, I just want to go back to tonight. So this is where the moon is tonight. Um, okay, so any questions of what we're looking at here? I want to show you some of the neat things that are going to be happening at different times in the month of May. But this is out all, you know, all spring. You can find these constellations. They vary just a little bit, like 4 minutes a night. The sky changes by 4 minutes every night. So we're looking south. Big Dipper is overhead. We arc to Arcturus, which is the bottom of the ice cream cone. And up to the left of the ice cream cone is the Corona Borealis, or the tiara, the northern crown. So we arc to Arcturus, spike down to Spica. Underneath the bear, or about halfway between the Big Dipper and the horizon this time of year, is Leo the Lion. And so there's some constellations and some stars that you can look for. I want to talk to you about a meteor shower that's coming up. So the night of May 5th and the early morning of May 6th, right? Because the night of May 5th becomes the morning of May 6th. The Eta Aquarids, it's a meteor shower. Um, you don't have to have Aquarius above the horizon to enjoy it, but somewhere after 11 o'clock at night, 11, 1 o'clock in the morning. And these things are worthwhile if you want to enjoy a meteor shower, to set your alarm clock. Nobody wants to stay up till 3 o'clock in the morning, but maybe you could go to bed at 9 and set your alarm clock and get up at 3 and go out, you know, for an hour or so and try to find some meteors and then go back to bed, or maybe you just want to stay up. But the Eta Aquarid meteor shower. So we're going to advance the time here, and I'm going to show you Aquarius. We're going to go towards the morning sky, and there's a couple reasons I want to go to the morning sky. So time is advancing quickly. So this is 4:30 in the morning now. Okay, 4:30 in the morning. You can see right here where I'm circling. That's the Greek letter Eta and Aquarids. That's where the meteors would radiate from. As I said, Aquarius doesn't have to be above the horizon. So, do you see one? There's a meteor that just went there on the screen. So you can see that this is the constellation of Aquarius. You can see the water jar pouring the water out of the water jar. This is Aquarius. Again, this is 4:30 in the morning. And above Aquarius, we got a dolphin, Delphinus. Kind of looks like maybe a little kite there, which is cool. But so you got to remember the date, May 5th to May 6th. It's okay, a day or two ahead or a day or two after, there still should be some meteors. But this is supposed to be a decent shower. The other thing to point out is Jupiter and Saturn. So before the sun is up, this is 4:30 in the morning, blazing planet Jupiter, and up to the right is the planet Saturn. Not as bright, but let's check out how bright they are. So one of the neat things about stellarium, see, it shows you up in the upper right here, magnitude -2.18. That's bright. It's brighter than the brightest star. And if I come over to Saturn, click on Saturn, it tells me Saturn a magnitude 0.72. So it's brighter than Spica. It's brighter than a magnitude 1 star, but it's not as bright as a magnitude 0 star. Okay. And there's all different, you know, kinds of information that you can enjoy looking at if you would like to. So, and those planets, Jupiter and Saturn, are going to be in the morning sky before the sun's up for a very long time. So it's not like you just have days to look at it. They'll be up there for a while. And interestingly enough, remember we started my chat talking about the Great Square of Pegasus? Well, here it is. This is the Great Square of Pegasus right here. And Andromeda is off to the left. This is Alpheratz, which is the shared star from Andromeda and Pegasus. So neat things going on in the morning, Jupiter and Saturn. Now, May is the month for the planet Mercury. So I'm going to jump ahead to the next day, which is going to be uh, tomorrow, Saturday. We're going to go to Saturday night because the sun is already set here, so there's not much we're going to do here. So there goes the sun. I'm going to switch around to the west because Mercury is going to be visible in the west. Okay. Now, unfortunately, I think this is kind of humorous. I can't get rid of this landscape here. Like this is a town in France, not Concord. But I can't get rid of that tree. And I'm going to adjust the date. I want to go to May 13th. Okay. And the neat thing about Stellarium is you can easily jump around with dates. So this is May 13th. Okay. Okay. So unfortunately, you can see it, right? You can see the word for Mercury right here behind the tree. What I can do, I can get rid of the ground altogether, and I can get rid of the atmosphere altogether. So you can see the sun has set below the horizon, because again, the horizon is like up here, okay? And the sun has set, and the Mercury and moon are right together. And look at this, the day before, which would be the 12th, the moon is, look at that, right next to Venus. So May 12th, after sunset, let's say a half an hour, 45 minutes after sunset, May 12th, the moon, and it'll be a nice crescent, a very, very slender crescent moon next to Venus. It'll be beautiful. And then the next night, on May 13th, the moon will be right next to Mercury. But important to realize, the sky is bright, okay? It's not dark. The sun has set about a half hour ago. So I got to get my ground back here. And of course, it's setting. I can't get rid of the tree. But you want to find yourself a nice low western horizon that's fairly flat. And 2 nights, May 12th, the moon and Venus. And then the moon will be a little thicker on May 13th, and you'll see the moon and Mercury, which is very, very cool. But wait, there's more. We're going to skip ahead to May 28th. So we're talking the end of May. And you see, it just says Venus right there. I'm going to get rid of the atmosphere. But I want you to see something. There's a zoom feature on this. So watch what happens when I zoom in. Can you see there's another little dot there? Let me move that up. You see there's another little dot there, right? And you can see it says now Mercury. Look at that. Mercury and Venus are going to be so close to each other, less than the width of a full moon, right? So if you can envision how big a full moon is in the sky, Mercury and Venus are going to be closer than the width of a full moon. But the sky is going to be bright. So, binoculars can help. It's not a black, dark sky like I'm showing you here. This is just so we can see them. But the sky is going to have some light because we're talking 30, 45 minutes after sunset. But they are both going to be bright enough to see them. If you have binoculars, binoculars are certainly, a treat.
Somebody else brought it up. It says, how can we have 13 zodiac constellations, but only 12 zodiac signs?
Well, I don't want to appear contentious or controversial, but the people who, I'm going to use the word invented, though that may not be the best word, but the people who put the zodiac together weren't paying attention. They got 12 instead of 13. And the interesting thing is, uh, there's 13 constellations that the sun goes through. And interestingly enough, the sun spends 3 times longer in the constellation of Afayucus than it does in the constellation of Scorpius. So if one should stay and one should go, if you only want to have 12, Afayucus should stay and Scorpius should go, because the sun is 3 times as long in Afayucus as it is in Scorpius. So it's just something that astrologers, so to speak, when they were putting it together, they missed it. And so the other thing also is, uh, when you look at, if you get an astrology book or your horoscope, you have dates associated with when you're born. Only 4% of people alive have their actual sign that they think they are. 80% of people are off by one constellation, and 16% of people are off by 2 constellations. So it's very rare that somebody actually has their birth sign that they think they are. Because your actual birth sign is, where was the sun when you were born? And if we were to go to your birth date and find where the sun was, what constellation was the sun in when you were born, that's your real birth sign. The chart is 4,000 years old and it's out of date and it's not accurate.
Wow, I love it. That's really interesting. Dave, I wanted to just say our program was an hour, so it's 7 to 8. So we're
Okay.
actually we are kind of out of time. And Dave, thank you so much for this incredible program. I hope many of you get to go out and stargaze tonight and continue to stargaze throughout the whole spring. And think of Dave. Yeah, we're giving you a big applause.
Well, thank you. You're so kind. Sorry I went over. I wasn't watching the clock.
That's okay. It's so much there. It's space. It's so big.
It,
um,
hey,
yes. So thank you and good night to everybody.